NCM Learning Center. Good morning friends. Now I am going to discuss about switching characteristics of various power electronic devices such as Diode, BJT, MOSFET, IGBT, SCR, TRIAC. Okay, it is one of the very important topics for electrical engineering students. Before the discussion of switching characteristics or VA characteristics of power electronic devices, the power electronic devices mainly tested classified into two parts. The first part is whether is it unidirectional device or bidirectional device. The second part is whether is it unipolar device or bipolar device. You have to check. Okay. So you should know what is unipolar device, what is unidirectional device. First, we will discuss. Unipolar device means based on the basic electronic concepts. The unipolar device is defined as if the device conduct by the only majority carrier, maybe the majority carrier may be holes or electrons, then the device is called as unipolar devices. For example, MOSFET is a unipolar device because the MOSFET have two types. One is N-channel MOSFET, another one is P-channel MOSFET. The N-channel MOSFET, only the carrier is electrons. It will conduct only by the majority carrier electrons, not by holes. In P-channel MOSFET, the majority carrier is holes. It will conduct only by the holes, not by electrons. So, the MOSFET is called as unipolar device. It is the definition based on the basic electronics concept. Okay. Bipolar device, based on the basic electronics concepts, the bipolar device is defined as if the device conduct by the both majority carrier and minority carrier, then the device is called as bipolar device. For example, diode BJT is a bipolar device because the diode have the N-type and B-type materials. PN junction diode, it have P-type and N-type. It will conduct by the holes and electrons both. Similarly, for BJT, NPN transistors, it have N and P electrons as well as the holes. So the diode and BJT conduct by the both majority and minority carrier, so the device is called as bipolar device. Okay, this is definition based on the basic electronics concept. But the definition is different for the power electronic devices concepts. So the unipolar device is defined in the power electronic concept is if the voltage across the device is either positive or negative, not both, during off time, then the device is called as unipolar switch. Example, diode and BJT. Later we will discuss why the diode and BJT is a unipolar device. Okay. The bipolar switch is if voltage across the device may be positive or negative during off time, then device is called as bipolar device. Okay, positive voltage and negative voltage both are possible during the device off time. Then the device is called as bipolar switch, bipolar device. Okay. Then unidirectional device means that if the device conduct only one direction, it will allow the current in only one direction during on time. Uni means one. Okay. Then the device is called as unidirectional device. Diode, BJT, SCR is a unidirectional device because diode always current flow from anode to cathode only. If the device does not allow the current flow from cathode to anode, only unidirection. So it is called as unidirectional device. Bidirectional device means if the device allow the current in both direction during on time, then the device is called as bidirectional device. Example, TRIAC. Okay. For the switching characteristics, ignore the basic electronics definition. Only remember the power electronic concept definition. Okay. Switching characteristics of ideal diode. We know the symbol. This is the diode symbols, anode and cathode terminals. We know the structure. B junction diode, so P-type holes and N-type electrons. During on state, internally the diode have a barrier potential, some barrier potential. For ideal case, it is 0 volt. For practical case, 0.7 volt for silicon diode. When Vin greater than the barrier potential, let us take an ideal diode. When the Vin greater than 0 voltage, then only the device will conduct. Otherwise, does not conduct. So the condition for the diode is on state is Vin should be greater than 0. Otherwise, the device will be off state. Now, when Vin greater than 0, the positive charge repel the holes. So the holes will move from P-type material to N-type. The electrons repels the negative charge repels the electrons, so the electrons will move from n type to positive. Now the conduction will happen. Current direction is the hole's direction opposite to the electron direction, so the current will move from always anode to cathode. But this concept is a bipolar device because the conduction happen by both electron as well as the holes, so it's a bipolar device based on the electronics concepts, but it's different, but it is different from the power dynamics concepts. But our objective is the power dynamics concepts. Okay, switching characteristics. During on condition, diode act as short, so we may replace the diode by short. So the voltage across the short means voltage across the device will be zero. Always current flow from anode to cathode. Okay, so it's a unidirectional device. By the on condition, we may test whether is it unidirectional device or bidirectional device. Okay, voltage across the ideal diode, voltage across the short is zero, so voltage across the device during on state it be a zero. During off state, when being less than zero, the diode will be off. When being less than zero, the diode will be off. So the diode acts as open. Now the voltage across the diode always it's equal to V in always less than zero. So there is no possible the voltage across the diode is positive. Only possible is negative. So the diode is a unipolar device. Okay, based on the power dynamics concept, it is a unipolar device, but based on the basic electronics concept, it is a bipolar device. Okay, so remember the power dynamics concept. Don't think about the basic electronics concepts. Okay, the diode is a uncontrolled device because not able to control the on period as well as off period, so it's an uncontrolled device. The switching characteristics, VI characteristics, the operating region is the second quadrant because the voltage across the diode always negative. Always the current flow from anode to cathode to forward direction, so this quadrant. Okay, this I represents the reverse direction. Okay, this is forward direction, this is reverse direction. This is voltage across the device is negative, this is voltage across the device is positive. Okay, if the current direction is both forward and reverse, the region will be this region or this region, this region and this region. Okay, this is the VI characteristics of the diode. Now we will discuss the switching characteristics of SCR. We know the symbol of SCR, same characteristics of diode, but it additionally have gate terminals. So by the gate terminal we can control the on period but not able to control the off period. Okay, during on state we may find whether is it unidirectional or bidirectional. We will check. During on period, when the SR will be on, the condition is Vin should be greater than 0 like as diode. Additionally, gate current should be positive. This is the condition. Vin should be greater than as well as Ig, gate pulse should be applied. Then only the SCR will be conduct. Okay, if any one is false, Vin not greater than 0 or Ig is equal to 0, if any one false, the SCR will not conduct. Okay, for on condition, the both conditions should be met. Okay, so like as diode, the current always current flow from anode to cathode. It does not allow the current from cathode to anode, so it is unidirectional device. Okay, when it's on condition, the SCR act as short, so voltage across a short is equal to 0. Off period, by the off period we may find the whether is it unipolar or bipolar. Okay, the first case, if any one is false, the SCR will be off condition. Okay, first case, being less than 0, but Ig may be a positive or negative, any one values. Okay, in this case diode is act as open, does not conduct, so the current, the voltage across the SCR is equal to Vin, so Vin is negative, voltage across the SCR is negative for this case 1. Okay, case 2, being greater than 0, being greater than 0 but gate pulse not applied. In this condition also the SCR will be off condition. Okay, now the diode will be open, no current flow, but the voltage across the SCR being greater than 0, so voltage across the SCR positive. Okay, so there is possible voltage across the SCR is positive or negative, both are possible during off time, so it's a bipolar device. Okay, the SCR is semi-controlled device because on grid can be controlled by gate signals but off grid cannot be controlled. Okay, the characteristics is because the voltage across the SCR is either positive or negative, direction is one, forward direction only. So the switching characteristics, that means VI characteristics, is first and second quadrant. Okay, third, switching characteristics of MOSFET or BJT or IGBT. The switching characteristics of MOSFET, BJT, IGBT both are same characteristics. Okay, so this is symbol of BJT, base collector emitter junction, MOSFET gate source drain, IGBT gate collector emitter. This is symbol of BJT, MOSFET and IGBT. Okay, during on state, always remember that always collector to emitter voltage is biased positive. Always collector to emitter voltage is positive. Okay, based on the base emitter voltage, base current, the device will goes to on or off. Okay, here always the voltage applied between drain to source is positive. Here also IGBT also always voltage applied between collector to emitter is positive, but on and off depends on the gate voltage. Here VB, base emitter voltage. Okay, when VB greater than 0.7, the device will be on. When VB less than 0.7, the device goes to off condition. Here VDS is positive, always drain to source voltage is positive, but if gate voltage is applied, gate voltage is positive, then only the MOSFET will be goes to on condition. If gate voltage is less than threshold voltage, it will goes to off condition. Similarly for IGBT, always collector to emitter voltage is positive, but when gate voltage is less than threshold, it will goes to off. Okay, same concepts. The BJT is current controlled device because on is depends upon the base emitter voltage, but the collector current is depends upon the base current. We may control the collector current by the base current, so it is a current controlled device. But MOSFET and IGBT is a voltage control device. Based on the voltage, gate voltage, the current, drain current or collector current is controlled. Okay, on state, the current flow from collector to emitter, it acts as short circuits, so VC is equal to 0 voltage. Similarly for MOSFET also, current always flow from drain to source because always collector to emitter voltage is positive voltage, so always current flow from drain to source. There is no possible to current flow from reverse current flow, emitter to collector or source to drain or emitter to collector. There is no possible. But in the BJT, in the reverse active region is possible. Reverse active is theoretically possible, practically not applicable. Okay. For using the device as a switch, it will act as saturation region or cutoff region. During the saturation region, always collector to emitter voltage is positive. Remember that. Okay, always current flow from collector to emitter. There is no possible current from emitter to collector or source to drain. Okay, so it is a unidirectional device. By the off state, when the SCR is, when the BJT or MOSFET is, when the BJT or MOSFET or IGBT is off condition, because always collector to emitter voltage is positive, so the voltage across the device is positive. Similarly for MOSFET also, there is no other possible, because collector to emitter, drain to source, collector to emitter, because this collector to emitter is biased to positive voltage. Okay, so only one polarity is possible during off state, so it is called as unipolar switch device. the device is fully controlled device because able to control the on state as well as the off period. The BJT is current control device because the collector current is controlled by the base current. MOSFET and IGBT is a voltage control device because the drain current or collector current is controlled by the gate voltage. The characteristics, the first quadrant only, because always the voltage across the device during off time is positive. There is no possible of voltage across the device is negative. Always current flow from one direction, unidirection, collector to emitter, not reverse direction. So the character region is first quadrant. The switching characteristics of MOSFET, BJT and IGBT with internal diode. Let us take, we know that MOSFET, BJT and IGBT all have the same switching characteristics. Let us take any one, BJT. Okay, BJT with internal diode. On grid, the composite switch, the composites are connected in parallel. If the composite switch are connected in parallel for on condition, anyone may be on. Okay, if anyone on, the current flow from top to bottom. If BJT on, the current flow from top to bottom. If diode is on, current flow from emitter to anode because diode connect only anode to cathode. Okay, so first case, let us take first case. BJT is on, diode is off. What will happen? If BJT is on, diode is off condition, the current flow from collector to emitter. Okay. Second case, BJT is off but diode is on. What will happen? The diode always conduct current flow from anode to cathode. So the current flow from emitter to collector. So for on condition, both direction is possible. The device allows both direction. So it's a bidirectional device. Okay, during off period, is a composite switch. It's a parallel. To turn off the device, both should be off. If BJT is off, what will happen? The voltage across the device is positive. Already we discussed. Okay. If diode is off, voltage across anode to cathode is negative. Anode to cathode is negative. If diode is off condition, anode to cathode is negative. So voltage across the diode cathode to anode is positive. So this voltage will appear during off condition. Voltage across the BJT plus to minus, voltage across the cathode to anode is positive. Anode to cathode is negative, but cathode to anode is positive. So always positive. Voltage across the device is always positive. No other way. It's a unipolar switch device. Okay. So these characteristics. It's a bidirectional switch. So top and bottom, forward and reverse direction. So both are possible. But the voltage across the device is always positive. So this region, first and fourth quadrant. This is switching characteristics of MOSFET or BJT or IGBT with internal diode. Okay. Next, gate 10 of thyristor. The gate 10 of thyristor is same characteristics of SCR, but only difference is the SCR not able to control the off grid, but the gate 10 of thyristor controlled both on grid as well as the off grid. Okay, that is the difference. But all others are same. So same that of SCR is a unidirectional device and bipolar switch. Okay. Next, TRIAC. If two SCRs are connected in anti-parallel, then the device is called as TRIAC. Okay. The gate terminal is common for both SCRs. Okay, SCR 1 and SCR 2. This is terminal 1, main terminal 1, main terminal 2. During on period, gate should be positive. Gate pulse is given. When MT1 greater than MT2, the SCR1 top SCR will conduct. Okay, so the current flow from MT1 to MT2. The second case, gate pulse is given. IG is not equal to 0, but MT1 is less than MT2. In this case, bottom SCR2 will conduct. So the current flow from MT2 to MT1. So it's a bidirectional device. Okay, it allows both directions, so it's a bidirectional device. Off grid, IG should be 0. When MT1 greater than MT2, the voltage across the device will be plus minus positive voltage. Second case, where Ig is equal to 0 and MT2 greater than MT1, in this case the voltage MT2 voltage will be higher than MT1, so the voltage will be negative voltage. MT2 voltage will be higher, MT1 voltage will be lesser, so it's a negative voltage. So both voltage are possible during the off period, so it's a bipolar device. So the switching characteristics of a TRIAC is all quadrant, because forward, reverse possible, positive voltage possible, negative voltage possible, all are possible. So first, second, third, fourth quadrant. This is VA characteristics of TRIAC. Now do it yourself for. We go to find the switching characteristics of the device, the composite device. This question is asked in GATE those three examinations. In the option A, the characteristics will be second quadrant, this region. In the option B, first and fourth quadrant. The region is this first and fourth quadrant. Option C, region is first quadrant. In the option D, region is first and second quadrant. Okay. The second question is asked in TNB AE 2018 examination as well as the GATE 2010 examination. We go to find the switching characteristics, IV characteristics of the composite device. Okay. Try and comment your answers. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.